let me set this up. But anyways, how's things going on your side, Han? How's things been? I think it's been 2 weeks since we've met, right? So
Yes, I just came back from vacation. So now I've been catching up with work.
that's good. That's good. Okay, I've got the recording set up, and let me share my screen to start. So it's been a while since you guys have been looking at this programming platform, so let's start with a little bit of a warm-up. So go to this website again, paperland.sg, and click try demo here. Click try demo. Key in your name if it requires you to, then it should bring you to this page. Yep.
Sorry, I forget how to turn it. Okay, so what's
So go to
website?
paperland.sg.
Paper.
So you click it, click try demo, and it should bring you to a page where you have to input your name, and it should show up.
Okay.
Amy, are you able to get to this page?
I'm typing my name right now and waiting for it. Yes, can you see my name at this moment?
Yes, I can. Okay, fantastic. Okay.
Okay, great.
So do look at my screen for now. We'll do a little bit of recap since it's been a while since you guys have tried this. So just take a look at my screen. So delete all the code you have on the left. For Amy, I think you should see a spiral, and for Han. Okay, so once again, to orientate you, on the right side is the command deck. These are some of the commands you can do. You can click on them. So this is how you toggle the command deck. You can click this, it will make it move forward. You click this is turn right 30. You can also type it, right? And you can also click it like this. So these are a couple of commands. So the task for you guys to do right now is to step 1, create a simple shape. So for example, let's say I want to make a hexagon. So let's say a hexagon looks like this. Forward and turn right 6 times. So I've got a hexagon. So what I need you guys to do is first draw a simple shape like this. Then next I want you guys to make it into a variable. So how do you make it into a variable? Well, we have to create a function. So you could, to create a function, what you do is you highlight this whole chunk of code, and you can click this. You can name your function something else. Let's say it's called hexagon. So you can click it, and it should populate the code like this for you. Yeah. So this is your custom function. You could type draw or you could type define. Both are alright. So once you have defined a hexagon, you could call hexagon at the bottom here, and it should draw, right? So that's how you could create a function. Then I want you guys to add a variable. So in this case, I want to add a variable called length. And what I want to do is I want to replace all of the commands with all of the forward commands with the length variable, and I want to be able to call it like this. Then what I want to do is I want you guys to create at this point you will have done step 2, which is make a function and make it into a variable. Function with a variable. Finally, I want you guys to make a flower with this. So what does this look like? It looks like this. A flower of different sizes. So 30, 20, 10, So your task right now to get you guys a little bit more warmed up is to do the same thing. So create your own simple shape, create a function around it, add a variable, and then create a flower by turning and drawing each of the shapes with a slightly smaller size. So that's the task. Is that okay? I see Han is following along. Amy, are you able to get instructions? Amy, I see you've dropped off. Are you able to hear me speaking, Amy?
Yes, I'm here.
Oh, are you having any issues?
Oh, but I think in my I can run this website really well, so I'm not at the same space as you guys, huh? That's weird.
What's...
Okay, I'll just let me try again. Because I'm now actually painting on my page now. Okay, now am I back again?
Oh, you're back. You're back. Yeah, yeah.
Oh,
Do you manage to hear the instructions?
yeah.
Fantastic. Wow, Han, your flowers is really nice.
Yeah, that's pretty cool. Oh my god, guys. And okay, I'll switch. Let me check. Actually, how can I find the place I gave previous when you set the hexagon definition?
Ah, okay. So that's a great question. So let's see. I have your code. If you look at my screen, I can show you how to do it.
Yep.
So take a look at the screen. Okay, so
Yes.
you could type it out, or if you want to, here's a shortcut. You can click this. The command deck should appear.
Uh-huh.
Right now you don't see anything. That's because you have not highlighted anything. So I'm gonna highlight your code here. See, once I've highlighted it, this
Yeah.
thing appears. If you click it, it will create
Uh,
a function, yeah, called my command. So you could change it here to, in this case, yours is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my god, I don't know what this is called. 9. I will just call this 8. And I click it. Right, so it'll write the function for you. So draw Amy. The do and the end represents the start and the end of the function. And then you see the Amy
yeah.
command is created. Yeah.
Thank you.
Yeah.
And hence, flower is beautiful.
Yeah. And if you try a different basic shapes, let's see, you can see what happens. Amy, are you able to create your own function? Ooh. Amy, I see that your code is not updating with your own function. Are you having any troubles, or is my computer just not updating?
I think it's my computer's problem. I'm not sure because I switch the name and also I'm trying to create more flower, but it doesn't show on my computer as well.
Do you want to share your screen so I can take a look?
Sure, sure. Okay. Can you see my screen now?
Yeah. Okay, I see your screen.
Yeah.
So there's an arrow at the bottom. There's a
Two.
Yeah.
Yeah. But even
At the
if
top,
I type do
nothing's coming up. At line number 1, do you finish typing that? Line 1.
Okay.
Line 1, can you delete that?
Oh. Okay.
Yeah, so there's just an error. So if you look at the bottom left side of your screen, it'll tell you the error. You see bottom left, right below, very bottom left below. It says error. Do you see the error? Yeah, function
Yeah.
FO. Yeah. There you go.
There you go.
Yeah, perfect. Okay, now I see it. Okay, excellent. Okay, cool. Amy, you could try to vary the size of the flower as well. We'll give it a few more minutes. You guys play around with your flower. Wow, nice flower. Oh. Nice, yes, good job, Amy. You can use a loop for it. Yes. We have the last 3 minutes. Finish up your flower. Oh wow, Amy, your flower is nice. Last 30 seconds. Okay, times is up. Time's up. Let's take a look at what you guys have done. Whoa. Han, how do you make this
Okay.
flower? Do share with us.
First, the first part of my code is still the first floor, the second. Sorry. Yeah, it starts from defining second current shape. The first half of the code is just shape.
Second flower, flower. So you didn't use the flower, so you only use second flower.
Yes.
Let's take a look. Oh, second shape. Ah, okay. A couple of pointers. So if you have functions, it's best to define your functions separately. So it's best to define this function outside of this second flower function. So it's good to have functions that only define one thing, then they can call each other. If you were to call a function, if you define a function inside of a function, it's not best practices because it's very easy to get confused. So this way still works.
Okay.
Does it make sense?
Yes.
Yep, it's to ensure that it's to ensure that it's easy to debug when there's error as well. Yeah, so that you don't have to see, okay, so if this function is inside this function that is called multiple times, then that gets really confusing. But yes, nice. Okay, so this first, or rather this second shape is a 9-sided thing, and then you just rotate it around it at 70. Ah, I see.
Yes.
Nice. Okay, cool. You could save it if you want, but let's take a look at what Amy has done. Amy, come share with us your flower.
Yeah. Let me check. Can you see the flower? Ooh. Okay, hold on. Okay, can you see the flower now?
I see this flower. Is this the flower?
Yeah.
What did you do here?
I tried to play a little bit, but and then so in the very first beginning, I drew the biggest part, like nine. I don't know how to call that, but 9 shapes. Flower first.
Right.
And I tried to rotate it. Yeah, drew the. And I think because what trying is also like how I want to divide it evenly, but I just like hand typing everything. So I think if I have more time, I will try to make it clear and short.
All right, cool. Well, it's still nice anyways. Looks like one of the Singapore flowers. Yeah. Okay, cool. Thank you guys for showing your flowers. So that's just a warm up to get you guys a little bit warm up with the coding interface here. So let's get into the meat of what we're going to be going through today, which is, so during the warm up, you guys learn how to use functions, right? So let's take a look at Hans code. Yes, you guys have created a function. So let's say this polygon is created here, and you guys could use it 40, 50, 100. Yeah, so you guys learn how to create a polygon, and you know how to add a variable to it, and you know how to call the function multiple times. So for example, if I do polygon 200, you get a larger polygon. So you guys seem pretty comfortable with something like this. what we're going to be exploring here today is what happens if, instead of you calling the function, what happens if the function calls itself. I'm going to repeat myself. So we're going to figure out what happens when the function calls itself. So what does that look like? Let's delete all of this and let me create a simpler function. Let's just call this function, and it does nothing right now, right? Let's make it do something simple. Let's ask it to do forward 100. Okay, nothing is showing up because I've yet to call it yet. So it's a function 100 like this. Correct? Now we can make it a variable. We can add a variable once again, length, and we can make this length, and we make it 100. Simple so far. Now my question to you guys is, what happens if I use the function to call itself? So see the function? I'm gonna add in a new function. I'm gonna add in a command called function here, and it's currently commented out because I don't want it to call itself yet. I want you guys to guess. What do you think will happen when the function calls itself after I've called it?
Does it draw the exactly same line? So nothing new happened, but it actually repeat twice.
So nothing new happens, it repeats twice. Is that your guess?
Yes.
Okay. So that's Amy. Han, what do you think?
I don't really know. I have no guess.
Have no guess. Okay, do you think that what Amy said it will happen? Do you think that would happen?
I have a vague idea that it's not repeating, but it will override something, but I don't know if it's right.
Override. So you think it will override itself. Okay, cool. Let's see what happens if I do this. Okay, nothing's happening here because the function itself is taking no length variable, because so by default it defaults to 0, so nothing is drawing. But if I make this 100, you see what happens? Why do you guys think this is what's drawn?
It's like 100 times.
100 times? So what if I'm going to change this to 1 instead. 1?
No.
Okay, so you see it draws make it 10, right? It draws a really long line. Why do you think that's the case when I get the function to call itself? To help you guys out, I'm gonna add a wait function. So I'm gonna wait for 1 second each time before it draws. Do you guys see what's happening?
It drew 10 times.
So it draws multiple times, because let's take a look at what's happening in the code, right? So on the code side of things, you could see at line number 8 I call function once, correct? And the function, this function is called, then it moves forward by 10, then it waits for 1 second, then it calls itself function 10, then it comes back to the top here, then call itself again, then it goes forward by 10, wait 1 second, then go function 10, and it does that over and over again, right? So function will call itself, function which then will call function, which then will call function, which then will call function, and it creates this infinite loop like this. That's why it's moving forward 10, 10, 10, 10 to infinity. Do you guys see that? Okay, to make things clearer, what I'm going to do is I'm going to make a small little turn each time. What do you think would happen right now? Are you guys able to guess it before it happens?
I forget how to call this shape. I forget the name of the shape.
Yeah, okay, so instead of 30, let's make this 60. Done, 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 done. Right. Do you guys know why it forms this shape?
It's more than, so after reaching back to the original point, which is 360 degrees, the rest four times will repeat the same path. So it didn't create something else other than the hexagon.
Yeah, that's right. Nice. That's why it's just drawing over itself, but it's not just doing 10 times, it's doing almost a lot of times. So see,
Okay.
so if I zoom out, this is what it looks like.
Yeah.
So it just functions 100 calling function 100 calling function 100. It just keeps going like this. So here's the interesting trick so what happens if I make this length not 100? So I'm gonna make this length like this, which is fine because right now function 100 goes into this function, which is when the length variable is 100, it goes forward 100, function 100 again, and then it does this. So nothing's changed. Now what happens if I add a +1 on this side? Can you guys guess what will happen? I'll use a smaller, so if I add a +1 or a +10 here, can you guess what will happen?
Become a flower.
Flower? Is it because we were working on flowers before? Yes, Han, what are you saying?
New shape will appear but with longer length each time.
New shape would appear but with the number each time, with a longer
length
each time. Okay, so Amy says a flower, Han says a new shape where the length will be longer each time. Well, Han is kind of right. It will be a function calling itself, but each time the length would be 10 times more. So I'm gonna plus 10 more. So it's gonna look like this. So you see this is longer than the previous one.
Yeah.
You see it's becoming longer,
That's pretty cool.
right? So it's getting longer and longer. So function 100 is calling itself. So it goes forward by 100. Then it waits for 1 second. Then it calls function 100 plus 10, which is 110. So then it comes back up here. It does function 110. That means it moves forward 110. Then it comes to here. There'll be 120, 130, 140. And if you want to see this go faster, you just make this wait slower, and it goes da, 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 da. Yes. So this is the power of calling itself. What happens when a function calls itself? It creates really interesting recurring patterns. or we call this loops. Okay, so this is a bit hard to see. So that's what you guys need to do right now. I want you guys to play around with the simple shape that you guys have. So delete everything else, just have your simple shape, and I want you to call your shape again and again. So let me give you a demonstration. So let's say your simple shape was like a square, right? And it has a length. And to draw a square, let's do forward 10, right 90, and you have a square like this, right? So I want you to explore what happens when you call itself and you increment the square. There you go. You add a weight function. And you can see what happens. You can see the shape growing in a very particular pattern. So the activity for you right now is to use your own simple shape. Remember, the shape should be simple because it's gonna create beautiful artworks from there. So keep your shape simple. Use this method of a function calling itself to make your shape grow. So the end result is that your shape must be growing in size. So that's the activity. Is it clear?
Yeah.
Okay, let's do it. Let's see how it goes. Ho ho ho. Yep, nice use of the triangles there, Han. Good job. Oh, yeah.
a question.
Yeah?
So, based on the code I'm typing now, it should be only repeat for like a certain time, but right now it just repeat unlimited, like just keep repeating.
Right. So
So
let me
I
take a
want to
look.
make sure it's my code. Yes.
Yeah, you want to make sure your code what?
Is it because my code or just my computer is getting weird?
Ah, I see. Okay, cool. First of all, you want to comment. So come and take a look at my screen.
Yep.
Okay, so step one, cause there's a lot of drawing happening, so your computer might get slow. So let's pause it for now by commenting this out. So what you want to do is you want to add a limit to this. So different computers have different abilities to do this. So that's why we actually have a secret stopping point so that the computer don't do this infinite times and crash itself. Yeah, but for you, if you want to define exactly when it stops, so this is how you do it. So Han, you can take a look as well. So before then, what you guys have is this thing just keeps going on infinity, right? So what we want to do is we want to define when it should stop calling itself. So you see the hex is calling itself hex, which is calling itself hex, and again and again and again. So how do you stop it is you need to determine when it should stop. So I would say that when the length is smaller than, let's say, 100, I want it to continue doing this. Like, so I'm basically adding a condition. So when length is, sorry, there's a space. When length is smaller than 100, it would go in and do this loop. And if it's not, the function will end. So this is what happens. Let's take a look. Does it end? There you go.
Wow.
So it ends when the length is above 100. Then even though it calls itself, but the function that it calls itself completes, then it will jump back up. So that's how you do it.
Oh,
Does it make sense?
thank you.
Yeah, you're
Yep.
welcome.
Let me try again.
Okay, I see you guys are having quite a bit of fun making your shapes animate and grow. So I'm gonna take a pause right now for you guys to come and take a look at my screen again. And I'm gonna add in some more things you can do by calling itself. So right now, each time hexagon is calling itself length plus 20 plus 2 here, right? So there are other ways you could play around with the function calling itself. The term is actually called recursion because it constantly recurs. So right now you guys are doing it for a function with a certain length, right? So forward length, wait 1, function length plus 1. So it does this, right? And the thing is, you don't always have to do it with just the length. You could create more than one type of variable. So I could add a degree here. So this is degree. And then each time the degree can stay the same or as 1, or it could be 10. Right, it grows. Okay, if I don't make the length increase, I just keep. So each time, if the length is the same, I get a circle, and the degree is the same, I get it just keeps doing this. And I could change the degree, right? I could make it such that it's plus 1. I don't know what will happen, actually. Oh, I see. Okay, yes. Interesting.
Oh.
I actually don't, yeah, wasn't too sure what would happen, but it makes sense. Okay, so this is what would happen. I mean, what I could do is I could make this minus as well. Oh. Ah, I see. Do you guys know why this occurs? And you guys can play around. So if it's a plus 1, then it does this. If it's a negative 1, it does this. Do y'all know? Can you guess?
So 0, the first one will be minus 1 and then back to 0.
Yeah, absolutely right. So it's 0, then it goes negative 1, negative 2. So it goes in the opposite direction. So right now it's going here. So if it's a plus, it will just grow straight, I guess. So it goes, yeah, cool. But anyways, my point is that you guys can also vary other variables like this. Negative 1. Then you get something else, right? So a couple of interesting things to play around. So do make your shape. We'll present your shape in 5 minutes. Would that be okay? Or are you guys done? Sorry?
Okay, I see. I see. Yeah.
You're done?
No, not yet. Not yet.
Okay, cool. A bit more time then. Whoa, harness. That's some crazy shit. Oh. I'll give it 5 minutes since the hour is almost up. Yeah, so 5 minutes. Play around. Yeah, feel free to go crazy and see whether you could discover anything interesting. So we'll present what our shape is and our findings in 5 minutes. Oh. Last minute. Finish up the shapes that you want. Okay, cool. Time's up. Time's up. It's time to take a look at what you guys have created. Who wants to go first?
And I don't know why everything here like it just disappeared. So
Okay, well, let's take a look at Han's code. Han, are you ready?
Okay. For me, just experimenting. It is not really I intended to draw.
Oh, how do you get this?
So I want it to be a curve. That's why I have the function content to.
Ah, you want it to be a curve, right?
Yeah. And then it's just experimenting degree.
Hmm.
So I put like just a random division. The degree just below 30.
So if this is 40 curves, 10. Interesting. So if you put 30, it curls and it does this thing.
Yeah. One thing because this is just experimenting. When I change the loop, like now the loop for the curve is 10 times, not 10 do. If I change it to 9, the if I change it to 9, the number of say the number of ends only be 2 ends, like a wave.
Where? Which line?
Like if you line number 63
Yeah.
by 2. Yeah.
So instead of plus 10, you
No.
do the
No, 57 for you.
57 here.
Yeah, if I change it to 49, so it become only 2 times like this. So it doesn't go anymore. Now I don't know why it is.
Interesting. Don't know why. Amy, do you have any idea? Whoa. Do you have any idea why that's the case?
You mean like have to be more than 9?
Somehow if she puts more than 9 or 10, if you put 10,
Yeah.
the pattern will continue. But if she puts
Ah.
9, the pattern stops at just 2 circles here. Any idea why?
Let me calculate it because. Okay, let me guess. I'm just guessing something relative to the degree. Somehow over 10, the degree calculation will be more than 360. I'm just guessing. I don't really know how to calculate in this case.
Yeah, I think Amy is onto something. So if you do 9, what happens is that somehow the degree adds up to some 360. So what happens is that, as you would know, like 360 degrees is the same as 0 degrees, right? It's also the same as 720 degrees. So perhaps when you do 9, it's just repeating on itself. So it's growing like this and just repeating over itself. So to see whether that's true, one way we could do is I could add a color change.
Oh.
So
No.
so let's see what happens. So it draws, right? You can see it is drawing back exactly where it was. So yeah, it goes in and comes out, and then there you go, it's back here again. So I think somehow the summation of your degree adds up to a multiple of something. So it's just moving along the same. So if it's 10, I'm guessing that it will not go back on itself. So it continues, right? So see, it continues, right? So maybe if we let this go on forever, I don't know. Maybe it will converge on itself. I'm not too sure. Okay, here's a secret.
It's really beautiful.
Yeah, really beautiful. Okay, cool. So I guess Han has kind of discovered a hidden property, right? When you have your curve function calling itself and you change its degree and you create this either a repeating pattern or a non-repeating pattern just by changing this number here. So you found a mathematical property of this specific curve that you've just created. So yeah, that's interesting. Cool. Thanks for sharing, Han. That's fantastic. That's cool. Okay, let's take a look at what Amy has done. Amy, are you ready to share?
Does it run by itself now? Because I don't know why, like, there's nothing showing up on my screen now. But I can see it's running on your side.
I see. Your pattern goes like it's growing larger and larger, I can see. But it's growing in
I added like a when function, like after the draw function length degree do when length is less than 200 do, so it won't go crazy. But somehow it didn't show on your side now, so
I think you might have an error, so it's not showing on my side. But this is cool too. It's going forever. It's basically each time it's growing twice, and the degree is adding 100, adding 40 each time. So 40, 360. So it will make a full turn, and then it will get larger and larger. I could see some of your pattern inside of Han's pattern. See, Han has this double pattern happening here, right? But I think for yours, because the length doubles, so then it grows larger and larger, right? Hans, she didn't grow her length, right? She only grew the degree. So yours is a combination of hers and also growing larger. That's why it seems to be doing this pattern. Wow. Interesting. Cool. Thank you for sharing, Amy. So yeah, so this is kind of the core of what I wanted to show you guys. So as a recap, previously you guys have always been creating a function like this, and then you've just called the function yourself separately, like maybe 6 and 10. So then you could call another function and you give it different variables, but it's you yourself calling the function. Yeah, but today, for the first time, we're using the function to call itself multiple times, and we can see a lot of crazy patterns that emerge, and we are able to find out certain patterns that occur in them. And so this property of a function calling itself is actually something that happens a lot in nature. So in nature, you have, for example, a tree that's trying to grow, right? When a tree tries to grow, the tree stem is like, I want to grow here towards the sun, right? Then it's gonna keep growing and growing and growing. It's trying to repeat itself and grow. Just like our cells, our cells, it cell divide and create 2 cells, and it cell divide and create 2 cells, and then eventually you got a lot of cells. So this process of a function repeating and repeating itself is very interesting, very common. And so next lesson, what we're gonna do is we're gonna make more sense of what we're seeing on the screen. So for example, right now you guys have only been varying the lengths in each of your functions. What you could do is you can vary other things. So for example, next week what we'll be doing is so one interesting thing that we could be doing is something like this. So this is a triangle, this is a square. So it's 3-sided polygon, 4-sided polygon, 5-sided polygon, 6-sided. And what happens is that the letter n will represent not the length. It's also not representing the angle, but it's representing the number of sides. And so how do you use this special trick of a function calling itself to draw increase the number of sides of a polygon? That's something we will be doing. Another thing we'll be doing is we're going to look at how to draw a snowflake, something like this. So a snowflake like this is where you have a like a jagged edge calling itself, calling more jagged edges, which then draw larger jagged edges, stuff like that. Let's make this go faster. It's drawing a larger shape and form something like a snowflake, right? So that's what you could do with this special thing that we've been doing. There's a name to it. It's called recursion. So this idea of a function calling itself, it's called recursion, and we're going to be playing around more with it in the next lesson. So yeah, that's it for today. You guys have any questions?
No.
No.
Okay, cool. So I'll end it here for now.